The process of digging a well in Africa typically begins with the establishment of a marker. This marker takes the form of a circular boundary on the ground, outlining the dimensions of the future well. This is a crucial step as it helps ensure that the well will be of sufficient depth and capacity to meet the community's water needs. Once the marker is in place, excavation can commence. The well's diameter is usually small, allowing for the passage of only 2 people at a time to lift the soil out of the well. To extract the earth from the depths of the well, a simple yet effective tool is employed: the bucket. This bucket, often made of metal or other durable materials, is tied to a rope. At the well's surface, dedicated individuals work tirelessly to haul these buckets filled with earth upward. As the excavation progresses, a wooden stick, positioned crosswise on a rope, serves as a rudimentary yet functional pulley system. This ingenious mechanism aids in the smooth movement of buckets, making the process more efficient. The manual labor involved in lifting these heavy buckets can be grueling, highlighting the sheer dedication of those involved in the well digging process. Gradually, as the digging continues, water begins to appear in the well. This is a significant moment, as it indicates that the well is reaching the water table, an underground layer where the soil and rocks are saturated with water. Locating this water source is essential, as it ensures a sustainable supply of water even during dry seasons. Once the well reaches an adequate depth, a steel frame is carefully lowered into the well. This frame serves multiple purposes. It provides structural stability to the well, preventing its collapse. It also acts as a safeguard against contaminants from entering the well, ensuring the water remains clean and safe for consumption. With the steel frame securely in place, the well wall casting process can begin. This step involves creating the walls of the well to prevent soil from collapsing into the water source. In many cases, concrete walls are utilized for their durability and strength. The process begins with the meticulous mixing of cement to create a homogeneous mixture. This mixture is then carefully applied to the well's outer wall to form a sturdy barrier. Unlike the earlier stages of excavation, which require teamwork to lift heavy buckets, the well wall casting process typically involves just one person. This individual is tasked with applying the cement mixture evenly to create a smooth and robust well wall. This is a meticulous and time-consuming process, but it is essential to ensure the long-term integrity of the well. As the final stage of well wall casting is completed, the well begins to take its definitive shape. The concrete walls encase the well, providing a protective barrier and maintaining the integrity of the water source. With the completion of this stage, the well is ready for use. The process of digging a well by hand is a testament to human resilience and resourcefulness. It showcases the dedication of individuals and communities in providing a vital resource, clean and accessible water. While it is a demanding and time-intensive endeavor, the rewards are immeasurable. A well dug by hand serves as a lifeline for communities, providing access to safe and reliable water, thereby improving the quality of life for all who depend on it.
In a small, close-knit village nestled by a slow-moving stream, residents had long relied on the murky waters of the stream for their daily needs. However, the time had come for a change. The village decided to take matters into their own hands and embark on the ambitious project of drilling a well. This venture would not only provide them with access to clean and safe drinking water, but also foster a sense of community involvement and self-reliance. The process of drilling a well began with a communal effort. The whole village came together, driven by the prospect of having a dependable water source. Their first task was to clear a suitable space for the well. This involved removing any obstacles and debris that might hinder the drilling process. The heart of the drilling operation comprised a specialized bit and bucket combination and a long 1-inch tubing with a T-bar at the top. This setup allowed for the gradual extension of the drilling depth as needed. Additional 3-foot extensions could be added as the well deepened. The extensions were ingeniously held together by easily removable pins, ensuring flexibility and ease of assembly. To prevent extensions from falling down the well during drilling, a footplate was utilized. As the villagers delved deeper into the earth, they added more 3-foot extensions, each carefully secured. The total depth of the current well kit had reached an impressive 45 feet. This depth ensured that the well would access a stable and clean water source. At a later stage of the well drilling process, the villagers required small stones, roughly the size of peas or beans. To gather these stones, they enlisted the help of the village's children, teaching them how to measure the stones using their thumbnails. Buckets and buckets of these pea-sized gravel were collected, with even the village chickens getting involved in the effort. The next critical step involved bringing PVC pipe to the village for the casing of the well. The pipe featured slots cut 1 inch apart and had a perforated bottom to allow water to filter in from the surrounding sand. To prevent the sand from entering the pipe, the bottom of the 4-inch PVC pipes was cut, heated, and closed over. This clever design allowed water to flow into the pipe while keeping out sediment. A long, thin bucket was crafted from 3-inch PVC pipe, with 2 bolts inserted through the top to serve as an anchor for attaching the rope. This rope and bucket assembly were used to retrieve water from the well. At one end of this bucket, there was an anchor point for the rope, while at the other end, a special valve was installed. This valve opened when the bucket submerged in water, allowing it to fill, and closed when it was pulled up, preventing spillage. With the preparations complete, it was time to insert the 4-inch PVC pipe down the drilled hole, which had reached a depth of over 20 feet. This pipe served as the well's casing, ensuring the well remained stable and free from contamination. The pea gravel collected by the children was then dropped down near each side of the casing. This gravel acted as a natural filter, further improving the quality of the water drawn from the well. To complete the well structure, the villagers prepared a concrete slab around the borehole. A deeper concrete plug was placed at the top of the casing to seal it effectively. The foundation for the slab was meticulously prepared, ensuring it would provide stability and longevity to the well structure. Traditionally, it had been the role of the women in the village to fetch water from the stream. With the new well in place, they were shown how to use this valuable resource. The well brought a newfound sense of security, knowing that the water it provided was free from parasites, diseases, and viruses. As the water flowed from the well, a sense of relief and gratitude washed over the village. No longer would they have to depend on the unreliable stream water. Now, they had access to clean, safe water right in their own community. The total cost of this well, an essential lifeline for the village, amounted to approximately 75 British pounds or 120 US dollars. It was an investment that would pay dividends in improved health and well-being for years to come. In the end, the well drilling project was not just about accessing clean water. It was about empowering a community to take control of its own destiny. The entire village came together, contributing their skills and efforts to create a vital resource that would benefit generations to come. It was a testament to the power of unity, determination, and resourcefulness in the face of adversity. This well, dug by their own hands, would forever be a symbol of the village's resilience and commitment to a better future.
The construction of the main foundation begins with the placement of a sturdy steel frame. This frame is typically composed of robust steel bars or rebars strategically arranged in a grid-like pattern. The primary purpose of the steel frame is to provide structural reinforcement and prevent any settling or shifting of the foundation over time. The steel bars are precisely positioned according to engineering specifications to ensure the foundation's stability. Once the steel frame is securely in place, the next step involves the installation of the tank walls. As mentioned earlier, these walls are constructed using iron or wooden plates, with each plate carefully aligned and spaced according to the design dimensions. The plates are secured to the steel frame, ensuring they are tightly fastened to create a solid enclosure for the cistern. Maintaining the correct distance between the tank walls is crucial for ensuring the structural integrity of the water tank. The predetermined spacing between the walls is maintained with precision to allow for the subsequent filling with cement. This space between the walls will serve as the core for the cement filling, providing additional strength and stability to the tank structure. With the tank walls in place and appropriately spaced, the gap between them is filled with a high-quality cement mixture. This cement filling serves several essential purposes. Reinforcement. The cement filling acts as reinforcement, strengthening the tank's walls and increasing their resistance to external forces such as water pressure and ground movement. Waterproofing. The cement filling helps create a waterproof barrier within the tank, preventing any potential leaks or seepage through the gaps between the walls. Additional structural support. The cement filling enhances the overall structural support of the tank, ensuring its stability and durability. To reinforce the main foundation floor, a process known as casting is employed. This involves pouring a thick layer of concrete over the foundation floor, covering the entire area beneath the tank walls. The concrete is meticulously leveled and smoothed to create a seamless and solid surface. This reinforced foundation floor provides critical support to the weight of the water stored in the cistern. Both the inner and outer walls of the water tank require additional strengthening measures to ensure their resilience. This involves applying a layer of cement to both sides of the walls. The cement is expertly mixed and skillfully spread over the wall's surfaces, creating a protective and reinforcing coating. This step not only bolsters the structural integrity of the walls, but also enhances their waterproofing capabilities, safeguarding the stored water from contamination. The construction of the main foundation for a water tank is a meticulous and critical process that involves multiple steps, each designed to enhance the tank's structural integrity, strength, and durability. From the installation of the steel frame to the precise spacing of the tank walls, the filling of gaps with cement, and the reinforcement of the foundation floor and inner and outer walls, every aspect of the construction is carried out with precision and care. The inclusion of a steel frame surrounding the tank provides an additional layer of support, making the water tank robust and resilient. Through these carefully executed steps, the water tank becomes a reliable and long-lasting solution for storing rainwater, benefiting communities in regions with water scarcity and contributing to sustainability efforts. To further fortify the water tank's structural integrity, a steel frame is constructed to surround the tank. This frame consists of robust steel beams or rods arranged in a manner that encircles the tank's exterior. The steel frame acts as an external support system, ensuring the tank remains stable and secure, even under adverse conditions. The concrete pillar serves as the main support for the water tank cover. Place it in the center of the tank's opening and ensure it is level and securely anchored to the tank's foundation. The pillar should extend above the tank's rim to provide support for the cover. For larger or heavier covers, support beams may be required to distribute the weight evenly. Attach the support beams to the concrete pillar and the tank's inner walls using steel reinforcing bars and secure them with screws, bolts, or nuts. Place the roof sheets over the support beams. Ensure that they cover the entire opening and provide adequate overlap for waterproofing. If using metal sheets, secure them to the support beams using appropriate fasteners. If using concrete sheets, ensure they are properly aligned and interlocked. Fasten the roof sheets securely to the support beams, ensuring they are evenly spaced and aligned. Use screws or bolts to secure the sheets, making sure they are tightly fixed to prevent any movement. To reinforce the outer wall of the water tank, apply a layer of cement. This layer serves both structural and protective purposes. Prepare a cement mixture to the desired consistency. Apply the cement layer evenly over the outer wall of the tank, covering the entire surface. The thickness of this layer may vary but should be sufficient to enhance the structural integrity of the tank's walls. Smooth the surface of the cement layer to create a uniform finish. This step adds an extra layer of protection to the tank's exterior. To ensure that the roof is tightly covered and waterproof, apply a layer of cement over the roof sheets. Prepare a cement mixture to the desired consistency. Apply the cement layer evenly over the roof sheets, covering them completely. This cement layer acts as a waterproof barrier, preventing water from seeping into the tank. Smooth the surface of the cement layer to create a watertight seal. After installation, establish a routine maintenance schedule. Regularly inspect the cover, roof, and outer wall for signs of wear, damage, or deterioration. Repair any cracks or imperfections promptly to maintain the tank's integrity and water quality. Installing a water tank cover with a concrete pillar as the main frame provides structural stability and ensures the long-term durability of the rainwater harvesting system. By reinforcing the outer wall with cement and tightly covering the roof with a cement layer, you create a robust and waterproof enclosure for the stored water. Regular maintenance is essential to extend the lifespan of the tank cover and maintain the quality of the harvested rainwater. This comprehensive approach contributes to water sustainability and helps address water scarcity challenges in your community.